Welcome to the second video of expanding brackets and factorizing expressions. We're going to start to look, well, we have to start to look at expanding brackets, single brackets, with a variable on the left-hand side. But before that, we have to actually go through some rules. So, as you can see on the screen, we're going to work with this algebraic rule. And this only works when we have something that has the same base. Sorry. So our bases are our big numbers in anything. So our base, it could be 3, and we could have an index of 2. We could have a base of x with an index of 2. Anything can be our base. Okay? So that means we could actually have x, y, all to the power of 2. So with this rule, if we have two things that have the same base, but different exponents, and we want to simplify it, all that means is that we just add their exponents or add their indexes. So let's look down at example 1. And these actually sometimes throw people off more than anything are just the single powers of x. Because I keep saying mathematicians, we're lazy. We leave off those ones on top, right? So x to the power of 1 times by x to the power of 1, well, they have the same base, so we can write them. We want to combine them together, and we're going to write 1 plus 1. So we get x to the power of 2, or x squared. Next, we'll look at example 2. So here, I'm just going to draw that little 1 in on the first x, just to help out. And we have x to the power of 1 plus 2. So our final answer is just going to be x to the power of 3. Let's look at example 3 now. Here, first thing we check, same base. Our base is x in each, so we know that we're going to be able to do something, some kind of simplification. So we have 2 plus 3 as per our rule. So at the end, we're going to have x to the power of 5. And the last example we're going to go through is what happens when you have something that has numbers and has some variables in it. When we have our leading coefficients, as we call them. So our coefficient on the x squared term is 4, and our coefficient on the single power of x is 2. So, well, what do we normally do when we multiply numbers? Well, we're just going to do that here. So we do 4 times 2, which is 8. And then we can check our bases. So x and x, great. So let's just apply our rule here too. So at the end, we can write 8x to the power of 3. Now, I want you to try out a couple questions. So at this point, I'm going to ask you to pause your video. And then once you're ready, or if you're stuck, then go ahead and I'll solve those out for you there. Right, so going through these, we have y times y, like we were doing before. If you'd like, write that little 1 up. You do not have to though, but it does help some people. So they have the same base. So y to the 1 plus 1 equals y squared. You do not even have to show that much work. I'm going to show you on question 2 what I mean. You can just state this. So this answer is y cubed, because we have y to the power of 1 plus 2 is y to the power of 3. So I'm going to go back to actually doing them in longhand. But here we have y squared times by y. So here we're going to have y to the 2 plus 1, and we get y cubed again. So if you notice, it doesn't matter which way we multiply y and y squared, we're going to get the same answer. Next one, we have y squared times y squared, so we get y to the power of 2 plus 2 equals y to the power of 4. And lastly, well, just because we have three terms now doesn't mean we can't do something with them, right? It might just be harder. So if you want to break it up and make your life easy, put brackets around a set and work with just what's in the brackets first. So I'm going to do just that. And I'm going to find, well, y times by y squared is y to the 1 plus 2. So we get y cubed. And then now we're going to times it by that y cubed that we had left there, and we get y to the power of 6. The other way that you could do that is just do it all at the same time. So we could do y, and we could just, oops, sorry, we could do y, and we do 1 plus 2 plus 3, and we could get y to the power of 6, just like that. So it just depends how you want to approach it. See you in the next video.